Hello, everybody. So these two men are two of the greatest offensive centers in NFL history. The person in the black and white photo is Jim Otto, and then the other person is Michael Webster. Had long careers in the NFL, sustained many injuries over the course of their careers, including many concussions. And they had very different experiences during retirement. Jim Otto is 86 years old. He's still alive. He's never publicly disclosed a diagnosis of dementia, although he's talked a lot about his injuries in football. Michael Webster developed dementia in his 40s, and he tragically died at the age of 50 while homeless, and was subsequently diagnosed with chronic traumatic encephalopathy, or CTE. And so this, to me, is a tragic story, but also a very hopeful story, because we see these wide differences in outcomes from traumatic brain injury. And the successful stories inspire me because they show that the human brain can recover from a traumatic injury. The people like Jim Otto have the answers in their heads. We just have to figure out how to get them out. And so our approach for doing that is to start with skin cells and turn them into stem cells, and turn the stem cells into brain cells. And then we can grow those brain cells in these clusters that we call organoids that you see here on the right. And they still have the genes of the person they came from. So in this video, which I think is playing, we've treated these cells so that they will illuminate when they activate. Sometimes they fire one at a time, sometimes they fire together, so we know they're plugged into each other and they can communicate. These patterns are random, they don't mean anything, but in your brain, these patterns come together in very elaborate patterns to be the ideas and the memories and the decisions that you experience. And so while this is still random, it's still a piece of human brain tissue, and that's a very exciting opportunity. So to study traumatic brain injury, we need to induce trauma in this culture. And the first step in that is knowing how much the brain deforms during a head impact. And that's actually pretty well known. Studies like the one illustrated in this YouTube video, if you could run the YouTube video, please, Tyler, will show, allow us to compute roughly how much deformation that's happening in this tissue during a head impact. Stop it there. And so then our job as mechanical engineers is to recreate that deformation in one of these little organoids. So we built this machine. The blue thing on top is going to crush the organoid, and the little cylinder, the piston underneath it, moves it up and down very precisely. So you put an organoid into your petri dish, and then you sort of sneak up on it, and then apply this very rapid, compressive trauma to it to induce this deformation. And when we do this, we see the power plants in the cell shut down, and we see the connection switch off, and we see leakage of the proteins that we see leaking from the heads of concussed hockey players. So we're dragging this disease into a petri dish where we can control the mechanics and the genetics and hopefully get to some of those answers that are going to help the patients out there that need the care. Thank you for your attention.